Hello and welcome back to my channel. Today we are going to discuss another past paper from Cambridge International AS and A level, and it is Pure Mathematics 3 970933 from May-June 2021. So let's start. Here's the question number 1. Expand 1 plus 3x to the power 2 by 3 in ascending power of x up to and including the term in x cube, simplifying the coefficients. So we have the expansion for binomial expansion for this, which is 1 plus x over n. It has to be 1 plus x over n, and this is 1 plus nx plus n into n minus 1 upon 2 factorial into x square, then n into n minus 1 n minus 2 over 3 factorial, and then x cube plus and so on. So similarly, if we compare, we have 3x in place of x, so we have 1 plus 3x to the power 2 over 3 as 1 plus 2 over 3 into 3x plus 2 over 3 into 2 over 3 minus 1 over 2 factorial, and then 3x square. And lastly, since they have asked us to include the x cube terms, so it is going to be 2 by 3 into 2 by 3 minus 1 into 2 by 3 minus 2 over 3 factorial, and then 3x cube plus and so on. So next we'll simplify. This 3 got cancelled with this 3, so we have 1 plus 2x, and here the next one, 2 by 3 is 2 by 3, and then 2 by 3 minus 1 is minus 1 by 3, so it become minus, and then 2 over 3 into 1 over 3, I took this minus outside, and then 2 factorial is 2, and then 3x square, that is 9x square, and the last term 2 over 3 is 2 over 3 multiplied by 2 over 3 minus 1, that is minus 1 over 3, and then 2 over 3 minus 2, 3 2s are 6 minus 2, so minus 4 over 3 factorial, that is 6, and then 3x cube, that is 27x cube here. Now we'll cancel this 3 got cancelled with this 9, this 2 got cancelled with this 2, and then here we have 2, and then here 3 into 3 into 3 27, and this 27 got cancelled, and minus minus become plus. Finally we got the answer, that is 1 plus 2x minus x square, and then here it is minus minus plus 4 over 3 x cube, and that's the answer in the ascending power of x, and that too including the term x cube. And here is the question number 2. Solve the equation 4 to the power x equals 3 plus 4 to the power minus x. Give your answer correct to 3 decimal places. Since the unknown is in the power indices, so first of all we'll try to make as a one term if possible, otherwise if it is linear, then we'll solve in that way. And let's check it. 4 to the power x, so we can write 4 to the power x as such. 3 is 3, and 4 to the power minus x means 1 over 4 to the power x. So if we at the beginning itself, if we replace 4 to the power x by, let's say, t, so we got this thing as t equals 3 plus 1 over t, and now we can simply multiply by t in like both the sides, so that we can remove this t in the denominator, and we got it as t into t square equals 3 into t, 3t, and 1 over t into t is 1. So finally we got it as t square minus 3t plus 1, sorry, not plus, it is minus, because this side it will come, and then it is a quadratic in t, that is quadratic in 4 to the power x. So we'll solve in that manner. We'll have t equals, by quadratic formula, minus b, plus 3 here, plus minus root b square, that is 9, minus 4ac, that is minus 4, so it becomes plus 4 over 2a, that is 2. So it is 3 plus minus root 13 over 2, and t is 4 over x. Now we have two cases. If we take plus sign, we'll get 3 plus root 13 over 2, and if we take negative sign, 3 minus root 13 over 2, which is going to be negative number, and 4 to the power x is a positive, that is going to be, we can say it is the growth, positive growth, exponential growth. It will never be negative. Hence 4 to the power x has to be 3 plus root 13 over 2, and without using the calculator we can directly write x from here as ln, not log here because the base is not e, log base 4 and the whole thing here, that is 3 plus root 13 over 2. Now we'll use the calculator to get the value. Firstly we'll write the whole answer, whatever we'll get on the calculator display, 0.861839 and so on. So till 3 decimal places this value is going to be 0.862, and that's the solution for this. And here's the third question. The parametric equation of a curve are x equals t plus ln t plus 2, y equals t minus 1 times e over minus 2t, where t is greater than minus 2. T is greater than minus 2. We need to express dy over dx in terms of t and simplifying your answer. So it is parametric equation and we need to find dy over dx. So first of all we'll find dy over dt, and then we will use dx over dt and we will divide it like this. So first of all let's find what is dy over dt, because we have the parametric equation. Since y we have in terms of t, so we can differentiate only with respect to t first of all, initially we can say. So it is, there are going to be two functions, so we are going to use a chain rule, product rule. So first function as such t minus 1, and differentiation of second function is e to the power minus 2t as such, and differentiation of this is going to be minus 2 e to the power minus 2t, plus second function as such, and differentiation of first function is means t minus 1 differentiation is going to be 1. So ultimately we got e to the power minus 2t common, and we are left with, here it is minus 2t plus 2 and plus 1 from the second term. So finally we have it as 3 minus 2t e to the power minus 2t, that is dy over dt. Similarly dx over dt, differentiation of x with respect to t, t differentiation is 1, ln differentiation means 1 over t plus 2, and by chain rule if you multiply the differentiation of t plus 2, that is 1, so it will not make any difference. We will take denominator as t plus 2 common, and then we are left with t plus 2 plus 1, which is t plus 3 over t plus 2. Now we have dy over dx. Dy over dx is going to be, numerator is 3 minus 2t into e to the power minus 2t over dx over dt, that is t plus 3 over t plus 2. We can transfer it in the numerator and we're left with t plus 2 into 3 minus 2t, and then e to the power minus 2 over t plus 3. And we can see we cannot simplify it further, so that's the dy over dx in terms of t. And here's the b part. Find the exact y coordinate of the stationary point of the curve. Stationary point means dy over dx, that is the first derivative is going to be 0, and from the first part only we had dy over dx as t plus 3 into 3 minus 2t e to the power minus 2t over t plus 3. I guess let's check it again. T plus 2 in the numerator, it is t plus 2 in the numerator, and 3 minus 2t and e to the power minus 2t. So for a stationary point it has to be 0, and we know denominator cannot be 0, and e to the power, this exponential decay, is not going to be 0. So ultimately we are left with t plus 2 into 3 minus 2t 0. If we have this two term, either of them is going to be 0, then only we'll get it as 0. So it means we have t plus 2 equals 0 or 3 minus 2t equals 0, means t equals minus 2, which is not possible because it says that t has to be greater than minus 2. So from here we'll get t equals 3 by 2. So that's the accepted answer, and hence y coordinate, y was, let's check, it was t minus 1 into e to the power minus 2t, I guess. Yes, it is the same, t minus 1 into e to the power minus 2t. So y coordinate of the stationary point at t equals 3 by 2 is going to be 3 by 2 minus 1 e to the power minus 2 into 3 by 2. So it is 3 minus 1, that is 1 by 2 e to the power minus 3. Now we have the fourth question. Let fx be 15 minus 6x over 1 plus 2x into 4 minus x. A part is to express fx in partial fractions. So since the denominators are the 1 plus 2x into 4 minus x, so we can use the first type, that is 15 minus 6x over 1 plus 2x into 4 minus x equals equal or equivalent to a over 1 plus 2x plus b over 4 minus x, because they are linear product. So if we multiply the whole equation by 1 plus 2x into 4 minus x, we are left with 15 minus 6x, same as a times 4 minus x plus b times 1 plus 2x. Now it is true for all the values of x, so we can substitute any value. I'll choose it wisely so that we can find the value of a and b. So if we choose x as 4, then this will be eliminated and we'll get the b value. So at x equals 4, it is 15 minus 6 into 4, 24 equals, this got vanished, and we are left with b times 1 plus 4 2's are 8. 15 minus 24 is 9, so it is minus 9 equals 9b, which gives us the b constant as minus 1. So we have b value. Now we can substitute x by, we have so many options. We can choose x equals 0 as well, but we'll choose x equals minus 1 by 2 just to make the parity, because we have chosen x equals 4. X equals minus 1 by 2 will give us 15 minus 6 into 1 by minus 1 by 2 will come 1 plus 6 by 2 equals a times 4 minus 1 by 2, that is plus 1 by 2, and this becomes 0 because 1 plus 2x will be 0. Now let's simplify. 15 and this is 3, 15 3 18 equals 4 2's 8 plus 1 9 by 2a. This got cancelled and we are left with a equals 4, means our partial fraction of our function fx become 4 over 1 plus 2x plus b. b is minus 1, so we can write directly minus 1 over 4 minus x. That's the partial fraction of this fx. p part. Hence means we are going to use the first part. Hence find integration from 1 to 2 fx dx, giving you answer in the form of ln a over b, where a and b are integers. So from the first part we have seen that fx is 4 over 1 minus 1 plus 2x, sorry, and then minus 1. We will check it again. Minus 1 over 4 minus x. 1 plus 2x, 4 minus 1 minus 1 over 4 minus x. Now since we are going to integrating this means we are integrating this. Well, I will reuse the definite integral afterward. Let's integrate it first. So first of all, 4 is constant, come out, and 1 over the linear means it is ln 1 plus 2x, and then we will divide by the differentiation of this, that is 1 over 2, minus again ln of 4 minus x, and dividing by the differentiation of 4 minus x, that is minus 1. So this will be cancelled, this is minus minus plus, so the integration from 1 to 2 fx dx become 2 ln 1 plus 2x plus ln 4 minus x. Now we'll use the property, though it is not required, but for now it's not required, but we'll use it. 2 will go in the numerator as a power, and then addition become multiplication, so it is 1 plus 2x whole square and then 4 minus x. I'm using this so that we can simplify it easily. So putting the limits, upper limit is 2 ln 1 plus 2 into 2, 4 whole square, 4 minus 2, minus lower limit ln 1 plus 2 into 1, 2 whole square, 4 minus 1 is 3. So it is ln 4, 5 square 25, 25 into 2, 50, minus ln 1 plus 2, 3 square, 9, 3, 27. Again using the property of log, ln 50 minus ln 70 is ln 50 over 27. So from here also, now we got the form, we can see that ln is being used at so many places. Here's the fifth question, that is the last question for this. By first expanding tan 2 theta plus 2 theta, show that the equation tan 4 theta is half of equals half of tan theta may be expressed as tan power 4 theta plus 2 tan square theta minus 7. Means we are going to use this addition of this tan, and the double angle also will be using. So we have this as a condition, tan 4 theta equals half of tan theta, and we have seen tan 4 theta, they have included also that we need to expand it. By expanding we will get 2 times tan 2 theta over, because it is tan theta plus tan theta, over 1 minus tan square 2 theta equals 1 over 2 tan theta. I use the property, the identity a plus b, tan a plus b is tan a but plus tan b over 1 minus tan a tan b. But since tan a and tan b both are tan 2 theta, so I have written 2 tan theta. So now again we have to use the expansion because it is 2 theta and we need to prove for theta. So again we have tan double angle, tan 2 theta is 2 tan theta over 1 minus tan square theta. So here it is, it become 2 times 2 tan theta over 1 minus tan square theta, and denominator 1 minus tan 2 square theta, tan 2 theta square, that is square of the same thing, 2 tan theta over 1 minus tan square theta equals half of tan theta. So let's simplify. We are going to get a common denominator, 1 minus tan square theta, 1 minus tan square theta, but here we square, so we'll get 1 minus tan square theta extra, so we can send it in the numerator. So it is going to be 4 tan theta into 1 minus tan square theta in the numerator, and then denominator we can see it is 1 minus tan square theta whole square minus 4 tan square theta equals half tan theta. I have taken the denominator LCM at the same time and taken sent the 1 minus tan square theta in the numerator. So now we need to prove that equation. So tan theta, this tan theta got cancelled. Next is we are left with, I'm doing the cross multiplication, 4 into 2 8, then 8 into 1 8 minus 8 into tan square theta, so minus 8 tan square theta, and the denominator goes that side, it is 1 plus tan square theta square, that is tan power 4 theta minus 2 tan square theta minus 4 tan square theta. Now taking all the terms to the left hand side, we have tan let's take it to the right hand side. So 0 equals tan power 4 theta minus 6 tan square theta plus 8 tan square theta plus 1 minus 8 equals 0, or not 0, we have written it. Next line I will write tan square theta plus 2 tan, it is tan power 4 theta tan square theta, then minus 7 equals 0, and that's what we had to show. See, tan power 4 theta to tan square theta minus 7 equals 0. And second part, that is the last part, hence solve the equation this. So hence means we have seen from this condition we had written it as tan power 4 theta plus 2 tan square theta minus 7 equals 0. So in order to solve this, we need to solve the equation this. We can substitute, or we can do it directly. Tan square theta is going to be minus b, in this case it is minus 2, plus minus square root b square, that is 2 square, 4 minus 4ac, that is plus 7 into 4 28 over 2, that become minus 2 plus minus 28 plus 4 32 over 2. We can rewrite this thing as minus 2 plus minus 2, because 4 into 8, so it is 8 here over 2. We can cancel this 2 and we are left with minus 1 plus minus root 8. Now tan square theta is a square number because it's a square, so it cannot be negative. So we are left with only one option, that is tan square theta is minus 1 plus root 8, and we can write as minus 1 minus root 8 is negative number, and tan square theta would always be a greater value, or maybe equals to 0, but it is not going to be 0 because theta is always in between 0 and 180. So now we'll solve this. It means tan theta equals plus minus root of minus 1 plus root 8, means two values. We'll get it from calculator. 1 plus 1.35, 2, and with the minus sign, of course, it is going to be minus 1.352. So we have tan theta value as this. It means theta value with the positive, it is going to be tangent inverse of 1.352, and from here theta equals tangent inverse of minus 1.352. Now we'll see it from the calculator. We have 53.5 degree, 53.5 degree, and it is 53.515 and all, but we require to write till 3 significant figure or 1 decimal place, and here it is minus 53.5 degree, but it is not acceptable because it's not in the range. So that for the theta, for the tan, we have the next angle as 180 plus the previous angle, that is minus 53.5. so 180, this is going to be 126.48 and all, so that is 126.5 degree, and we'll not add 180 in this first angle because it will go beyond 180 degree. So ultimately we have our solution as theta equals 53.5 degree and 126.5 degree only, no other possibilities are there. So I hope it was of some help. Let's have the other questions in the next video. Till then, thank you so much.